Hello everyone. Today we are going to talk about our assignment 2, which is pressure in pipe. I'll introduce myself. My name is VEGANDARAN unlike MAHENDRAN, and here's my teammate NURUL FATIN HAZIRAH. Introduction. This project is about how fertilization works in a way of growing vegetables with advance of minimizing amount of watering. Two types of pipe configurations may be applicable for the watering process, namely straight in line or closed loop. The straight line have 5 holes and the close have 10 holes. These two different configuration will give variation in terms of flow rate as well as the volume of water received by each plant. This situation later will affect the quality of a plant itself. The result has been record and analysis to prove that different value each configuration. Here's the video.
Hello, hi. I know HAZIRAH AMIN. I will talk about this straight line water hole configuration. This here is the we have 215 cm straight pipe, and we have here five hole to bed. And 5 hole, we can calculate the pressure, the flow rate, and the velocity. Next one is next. Next one is close low. Next close low water hole configurations. Here we use 515 cm pipe, and we use 10 hole in here. Okay, next. Here how we measure. We use 200 millimeter volume of water, and when we just start to take in the water in the glass, we start the time until full 200 millimeter. We start the time, and here next, and here the result from the straight line water hole. So the whole one, we will talk about volume. Volume we use 200 millimeter, and the time from whole one we get 22 second. From whole two we get 15 second. From whole three we get 12 second. Whole four we get 10 second. Whole five we got 8 second. Flow rate, velocity, and pressure later I will explain in calculation. The maximum achievable water is the higher upon hole to the higher achievable. So from the whole one we get 50 cm. The second hole we get 13 cm. Third hole we get 15 cm. From hole 4 we get 7 cm, and the last one 5 we get 3 cm. The next, this is a result for the closed low water hole configurations. From the whole one, the time we get is 20 second. The hole 2, we got 50 seconds. The hole 3, we got 13 seconds. From hole 4, we got 10. Hole 5, we got 6. Hole 6, also 6. Hole 7, we got 10. Hole 8, we got 20. For 9, we got 50. For 10, we got 20. The maximum achievement water from the whole 1, we got 15. Whole 2, we got 13. Whole 3, we got 16. Whole 4, we got 7. Whole 5 and 6, we got 3. Whole 7, we got 7. Whole 8, we got 16. For 9, we got 20. And for 10, we got 15. Okay, next. This is a flow rate calculation for the straight line water. For the original formula, we got Q equal VA. Q is a flow rate, V is a velocity, A is area. But velocity we cannot get. We use the other formula is Q equal dA per time. D is calculation pressure for the straight line water water hole. Pressure calculation we use Bernoulli principle. After we simplify, we get pressure equal the water achievement Z multiple with the density of water multiple with gravity minus the velocity power 2 and divided with 2 gravity. This calculation for the velocity. We also use the Bernoulli principle. So we simplify. We get a velocity root power with 2p per density. To pressure with density.
So here's the conclusion. From this project, we got to know pressure variation in hose pipe over a specific pipe length with two different configurations. Flow in pipes will experience losses and will affect pressure distribution as well as velocity and flow rate at multiple locations and exits. Using Bernoulli's principle, we can calculate pressure each hole, flow rate and velocity. The straight line have decreasing pressure, increasing flow rate and velocity from the hole until the last hole. Meanwhile, the closed loop are increasing in pressure at beginning, then later in half way is decreasing but come back higher at the end. Flow rate and velocity is at higher at beginning, but in the middle is low and the end come back higher. At this point, we can decide pressure, flow rate and velocity in opposite each other. Thank you.
Thank you.